We also have expectation and experimental probability to look at. Again, these are things that you have studied lower down the school, so we'll just recap it. Expectation is when a question asks you, predict the number of times you expect a head to be face up. So how many times do you expect something to happen? So you'd know the probability, you'd know the number of times you were doing it. And experimental probability is when we find out the chance of something happening by running lots and lots of experiments, and then we can find the probability from that. It also ties in to relative frequency. So let's look at expectation. A fair coin is flipped 14 times. Predict the number of times you expect a head to be face up. Well, the probability of it being a head is a half. So you would expect half the times to be a head. So you'd expect 7. For part B, have a read of that question, where it says the probability of student being absent is 0.05, and how many would you expect to be absent? So the probability of absent is 0.05. There are 531 students in the school. So you would expect it to be 0.05 of the 531 students. And that leads us to 26.55. But we wouldn't have 0.55 of a student. You can round to 26 or 27, or you can state that why you've chosen 26 or 27. You can state both. So predict the number of students you would expect to be absent. So 27 absent I would go with. So I'd round up. Depends. If it's near the end of term, probably more. Which leads us on to part C, the assumptions you've made. Well, you're assuming that the absences on all days are equal. Whereas actually, we all know that you're more likely to be absent at the beginning or the ends of terms, when there's a test, when you've got work due the next day, that sort of thing. So absences, the assumption we have made though is that it's equally likely all through the year. This is a way that we can arrange data, a table. It's a bit more organized. It's grouped data, and these are the frequencies of each of those grouped data divided up. So have a read of the question. Having read through the question, it's a good idea to add in the totals for each of these. So we add in, we're going to add up the totals. So there were 305, 529, 286, and 210. And then here we're going to have 370, 419, 247, 294. And if I just check that I've done that right, add up this column, add up this row, then my total I can see is 1,330. So just make sure that you've added those up and you can do it. So then it says a tourist is chosen at random from the survey to receive a proportional offer to determine what age group the tourist is most likely to belong to. Well, they're most likely to belong to this age group, the 31 to 50. And that would be a 1-mark question in an exam. And that's because this number is the highest number. There are more of them, so it's more likely you would choose someone from that age group. The probability that the tourist belongs to that age group, well, the probability that they are between 31 and 50 would be the number of people that are in that age group divided by the total number of people. You can simplify that. You can leave it like this. You can give it as a decimal. I would leave it like this. And then for part C, 16,000 tourists are predicted. The town's hotels have capacity for 5,000. Predict if the town has enough hotel capacity to meet the demand. So you can have we would expect the number of people to choose a hotel would be the probability. So we would expect, if it's in the same ratios, we would expect 370 out of 1,330 people to choose a hotel. So if we're going to have 16,000 people, we would just multiply that by 16,000, and that gives us 4,451. I've rounded that answer. Therefore, we would expect there to be sufficient capacity, because that's less than 5,000. Always answer the actual question. So we looked at one way of showing the data. We also have Venn diagrams. So we have Venn diagrams where we do a rectangle, which encompasses our universe, the universe that we care about, and then we will have circles, ovals, whatever in here for option A, option B, hotels, cafes, whatever. And where they overlap, that's where the two happen at the same time. So when we have more things happening. So if we have a look at this example. So if you read this question, you can see there's a lot of information in there. So pause the video, read the question. So we can show this information in a Venn diagram. So inside the rectangle is our universal set. We have Ricardo and James. They study Spanish, but they also study ESS. So we'll call ESS E. And Ricardo and James also study Spanish. Then Malena, Daniel, and Maria only study ESS. Then you have the people who study geography. Of them, India studies geography in ESS, and you have Pietro, Matea, and Hanin that study geography, and Sophia and Yulia that don't study any of those. We don't really care about the names of these people once we're looking at them in this way. So actually, it can be much better to just put the numbers in. So we have 2 people that do Spanish, 3 people that take ESS, 1 person that does ESS and geography, 3 people that do geography, and 2 people just on the outside there. And that's how we see a Venn diagram usually. And we would also describe what our letters stood for. So, using that Venn diagram, we need to find the probabilities that a student chosen at random from this class is one of these. So I'm going to draw a neater version of the Venn diagram. So the probability that someone chosen at random studies ESS is the probability that they're in E. Well, we have 3, 4, 5, 6 people in E. And there are a total of 11. So 6 out of 11. So that's part A. Part B, the probability they study ESS but not Spanish. Remember, that's a sign for complementary, so not Spanish. Well, that would be 4 out of 11. Part C, studies all 3 subjects. Well, no one studies all 3 subjects, so that would be 0. And D studies exactly 2 of the subjects. Well, we have these 2 and this one. So that would be 3 out of 11. And so it's that straightforward. We just use the diagram to help us get the numbers. Have a read of this question. Pause the video while you do that. Not all questions will tell you to draw a Venn diagram. You'll need to know that that's the best thing to do. We know that it is because we're doing the topic Venn diagrams. But in your exam, you'll have to be able to spot that. So here we should draw a Venn diagram. It makes it much, much easier. We've got 26 students and we've got geography and history. So we're going to have 2 circles and there'll be some sort of overlap. So 10 study geography, 16 study history, and 4 don't study anything. So we've got 4 on the outside. Now we know that the total of this circle is going to be 10, and the total of this circle is going to be 16. But if we add this together, we're going to get 30, but we're only supposed to have 26 students. So we need to find out how many study both history and geography. And we've been given that clue because it's part A. So there's more complicated and less complicated ways of doing this. We can use algebra. So in here would be, if we say there's x here, so this one would be 10 minus x, and this would be 16 minus x, because this whole circle has to add up to 16, this whole circle has to add up to 10, and then we know that 10 minus x plus 16 minus x must equal 22, because it's 26 minus 4, isn't it? So if we simplify this expression, we're just going to get 26 minus x equals 22. So we know that x in this case equals 4. So there's going to be 4 people here. So this one, let's put them in a new colour. So 10 minus 4 is 6, 4 and 12. So hence find the probability that a student selected at random from this class studies exactly one of these subjects. Well, it's this 6 and it's this 12. So it's going to be the 12 plus the 6 out of all 26, which is 18 out of 26, and that actually simplifies to 9/13. You have a calculator that will do that simplification for you. So that is expectation and experimental frequencies, probability, and using a Venn diagram. You can now go on and do exercise 7C from page 313.